Good day, everyone. You're welcome back to the page. Thank you all so far for subscribing, liking, and sharing. God bless you all. This particular video is for possible questions on question 2 in the Waec 2026. So we were given lecture as a cabinet 4, that's PbCO3 and starch to provide as our specimen for C. So obviously we can create all the possible questions by knowing the specimens. So this is for the students and for anyone who would like to understand or to listen. Thank you. Now let us proceed. So C plus water, which is the first test. They say put C in water and then filter and then test with litmus. So here is the observation for that. C plus water, C would not dissolve because C is a mixture of PbCO3 and starch. So C would not dissolve. That C did not dissolve. If C did not dissolve, the inference there is C is insoluble in water. Then obviously the next one is plus filter. Plus filter, you will get a white residue and a colorless filtrate. It's always important we highlight the color of the residue and the filtrate. It makes it easier for us to proceed in other things. Then plus litmus, we're not checking if obviously if the C itself, if it is acidic, basic, or if it is neutral. It must be one of those three. So we use the red and the blue litmus paper. After testing with both of them, there was no effect on C plus water. So that means C is a neutral solution. Or they could start it with adding a particular acid, HNO3, because that's what they provided for us. So that's what they asked us to provide rather. So the C plus water would go, or the C plus HNO3 would go. It can only be one of these two. That's why I put or in the middle of both of them. So C plus HNO3. C plus HNO3, effervescence occur, you will get a colorless and odorless gas. Then you can confirm that gas by passing that gas through a lime water. Lime water has the formula of calcium hydroxide, that is Ca, open bracket, OH, close bracket 2. There has to be aqueous there. All of these things has to be aqueous. That's how the test goes. If you write the wrong test, they will not mark your observation. Neither will they mark your inference. So proceeding. As effervescence occurs, you don't know the gas, but once the gas can turn clear or colorless lime water, milky, you have a particular idea. So the gas is obviously at this stage is CO2. CO2 from CO3 minus. Now you filter. If you filter, you get a white residue and a colorless filtrate. That particular filtrate itself is acidic. You can look at the bottom of this page. You see the filtrate is acidic if it is tested with what? Litmus paper. That is, it will turn blue litmus paper to red. Now let's go to the other test. Before we do the other test, they will ask you to kindly divide the portion of the filtrate. Divide the filtrate into different portions rather. So it could be 3 portions, it could be 4 portions, depending on how many tests they want to do. Might as well be 2 portions, or even just singular filtrates, depending on the marks that is allocated to this question. So I did when I divided the filtrate into like 4 portions, so that I can do many tests, many possible scenarios for lead 2+. Now for the first portion of the filtrate, if I add NaOH, which is in aqueous, in drops, I will get a white or a chalky precipitate. So anytime you see white chalky precipitate, there's only 2 possible ions, that is lead 2+ and calcium 2+. While the gelatinous means that it's either zinc 2+ or aluminum 3+. So obviously at this point, we add it in drops to get a white chalky precipitate, that's lead 2+ or calcium 2+ present. Why? If we then add it in excess, that to know if it dissolves, it is lead. If it does not dissolve, it's calcium. But since we are testing for lead, it will definitely dissolve. So if you add the NaOH in excess, the precipitate is soluble, simply means that it dissolves. And then as it is soluble, it will form a colorless solution. That tells us that lead 2+ is present. So we take another portion of the filtrate again, and then obviously we add ammonia now, solution in drops. We'll get a white precipitate. Because we initially had already Pb2+, our inference here is easy for us to just say it is Pb2+ still. Now, if you then add it in excess, it would not dissolve, unlike NaOH. It will not dissolve. So the precipitate here will be, precipitate is insoluble. Again, Pb2+ is what? Present. While if you as well, if you take another portion of the filtrate and add, dilute HCl, we'll get a white precipitate. Or if we take the solution from BII, the solution from BII is when we added ammonia in drops and in excess. If you take that solution and if you add dilute HCl, we'll get a white precipitate. A white precipitate here is more likely lead chloride as a precipitate. So that means that Pb2 plus is what? Present. Now for us to know if it is truly lead chloride, because we are assuming now in our mind, if I add HCl to anything and I'm getting white precipitate, it should be like lead chloride, PbCl2. But let us confirm it. And how do we confirm it? We confirm it by warming or heating it and allowing it to cool. Lead chloride is the only thing that can do this next part. If we should warm it, that white precipitate dissolves. Why? If we then allow it to cool, the precipitate will reappear. So it simply means that lead chloride is present. We see that Pb2 plus is actually what? Confirmed. Then, if we now take the portion of the filtrate again, the last portion of the filtrate, and add dilute H2SO4, we will still get a white precipitate. Again, this is a confirmatory test for lead, because PbSO4 is also a white precipitate too. So in a nutshell, Pb2 plus is also confirmed. Now that's all the possible tests for lead. Now if you get to the other side, which is the carbonate 4, although we've already done something that looks like it from the beginning when we did C plus HNO3. If effervescence occur, the gas is CO2 from carbonate 4. That's CO3 2 minus. So if we now decide to do another test for carbonate 4 ion, we will take the residue, because the residue will contain more of the carbonate 4 ion, because that one is highly insoluble. So then the white, if you take that residue rather and add barium chloride, a white precipitate can tell us that it can either be SO4 2 minus, that is the Charles of a 6 ion, SO3 2 minus, that's carbonate 4 ion, or CO3 2 minus, that's carbonate 4 ion also. So Waec could mark either out of these three. Waec could pick 2, including the CO3. They either pick SO4 or they pick SO3, and then they will pick the CO3 to make it 2 marks. So this is always 2 marks. The inference at this side is always 2 marks. So to confirm which one is it, HNO3 is added. If the precipitate dissolves so fast, as rapidly, and if effervescence also occurs simultaneously, it means that the radical here that is present is CO3 2 minus. Then the last test, obviously, is when we have the residue again, and then we add iodine solution. Iodine solution will produce a blue-black color that you will see in your test tube. So that will just tell you only one thing: starch is present. So from all indication, that is the whole thing. Whatever test that you do, if you are doing a test that confirms Pb2 plus, at the end you must write that the cation is Pb2 plus. Or if you are doing a test that contains an ion, that confirmed an ion, at the end that confirms is CO3, whether 2 minus. That means at the end you must write that the anion present is CO3 2 minus. Whichever ion you confirm, you must write at the bottom. That is also another kind of mark in Waec. Even the organic compound that we did, that we say starch is present. If we should do the test, we must also confirm it by writing it at the bottom. So that is everything on qualitative analysis. If you know this table very well, I want to believe you should get all the possible marks from question 2. Thank you so much. God bless you all. Thank you for watching.